Well, hello. Thanks everybody for coming. Really excited to see so many people interested in MCOM and integration with MCOM. My name is Sergey. I'm a software engineer from Magento Commerce Order Management development team in Barcelona. And for quite some time already, I've been working on the integration layer of Magento Commerce Order Management System. And I'm very excited to tell you about it today. So before we get into it, I would like to recap a little bit what is Magento Commerce Order Management. It's a new product of Magento that joined Magento family relatively recently. It's a modular, cloud-based platform designed to provide centralized inventory, order, and fulfillment capabilities that enable commerce businesses to deliver a consistent, low-friction, omni-channel experience to the customers. Why integration is important for this? Why integration for this product is important? Here's our MCOM sitting there in the cloud, waiting for orders to arrive. And at some point, MDC or customer service agent or in-store application makes a request to MCOM and places a new order from the customer. And this is where order fulfillment process starts, which involves multiple steps. And most of those steps involves remote system communication. So, for example, payment, in order to validate payment, your OMS, MCOM, are required to make a call to the payment service and verify that payment is valid. Then for starting a shipment process, it's required to send a request to the warehouse management system in order to create a shipment request and start shipping process. So all of those systems out there, the MCOM, one of those features is to be an orchestrator for all of those systems, to make them work together to fulfill the order. And most of the processes that are, sorry. So most of those processes are, as I said, require a remote communication. So remote communication with a system that normally already is in the client infrastructure. So we cannot just build a solution which will do everything, every step of the order fulfillment, and even if it would be perfect, even if it would fit needs of every client, it still will be too hard to migrate to. I mean, there are so many clients that already have this. So instead of building a complete solution, what our strategy is, what MCOM strategy is to provide an integration API which will allow partners to build those glue between systems that are already there with a client and MCOM. So from integration point of view, MCOM could be described as a powerful state machine which knows exactly at what time, what action to execute for a given order. And when normally those actions, they are asynchronous. So you send a request saying, hey, please do this, start the shipment, assess the fraud or whatever. And OMS, MCOM can carry on. And once the action is done, it will need to receive some confirmation and then trigger a next action. For example, if we would review the integration between warehouse and MCOM, so at some point, MCOM will decide, okay, it's time to ship something. So it will make a request to the warehouse requesting shipment. Then somebody in the warehouse agent will see the request and will start collecting items, checking stock, whatever he needs to do. And at this moment, MCOM don't need to wait for response. It really can carry on, take care of other orders, while warehouse will be processing this request. And then once request is fulfilled, there will be another request to notify that the request was fulfilled. So So this really shows that most of the processes in MCOM are really asynchronous. They have asynchronous nature. And it's not applies just for warehouse. It's actually any integration with any service, with most of the services that MCOM integrated with is asynchronous. So we really wanted to make this integration easy. We wanted to make it easy to implement, easy to understand, easy to extend. In Magento Digital Commerce, extensibility achieved by allowing developers, allowing partners to put their code in the same code base as the core code base and build customization, right? And this is very important for MDC because MDC is a customer-facing product. You really want to create this experience that you want to show, that you want to deliver with your brand. You want to build this branding around your customer's experience. And this is why it's so important to have full control of the code, have been able to customize literally everything in how your front end behaves. If we look at the MCOM, we can see that the goal is different and the needs are different. So the system is a SaaS offering from Magento, so you don't have access to the code. But you you basically don't need to build deep code integrations as well, because this is not one of the systems that faces your clients. This is not one of the systems that should tell your story, your brand, deliver this experience to the customers who want to buy something from you. This is one of the systems that sits on the back and orchestrates the order process. It manages your inventory and so on. So the strategy for customizing MCOM is really about building integrations, building applications which are using MCOM API to do what they need to do, to communicate with that warehouse management system that is unique for this client, or do a fraud assessment with a payment methods that are available only in one country, and so on. So what we started from? We started from defining a specification. Some way of describing what you can do with MCOM. So our goal was not really to produce, a huge amount of documentation which will tell you what to do, how to do, because we believe that documentation goes out of date really fast. So instead, we choose to describe it in machine-friendly format that you will be able to parse, that you will be able to use for generating human-friendly documentation, for maybe code generation, validation, and maybe some other automated processes. We choose simple XML format, which describes data structures that you can use, interfaces that are exposed by MCOM, and those are really similar to what you have in API folder of Magento 2 modules, if you had a chance to look there. It's very similar, but it's unlike PHP interfaces, XML file is way easier to parse, and you can use it for code generation. So you can actually generate interfaces out of this XML file. You may find this idea very similar to, let's say, VSDL, XSD, or JSON schema, and it is really similar and maybe perceive the same purpose. But we start considering those formats at first, and we found them quite complex. They do what they're supposed to do, but writing them, parsing them, is quite a challenge. So, we started trying to with XSD a little bit. I played a bit trying to build a code generator out of XSD, and there is so many features. It's just crazy how many of them, how many ways you have to describe same data structure. So we choose our own XML format. But in case we change our minds, or in case we realize there is a better industry standard alternative, because it's machine readable, it's still quite straightforward to convert it to something else. And actually, you can use it, for example, if you require VSDL, for example, you still can create a small PHP script, whatever script, to convert one to another. So let's look inside. And what you will find inside is, first of all, data structures. So data structures are simply sets of fields. Every field has a name and type, very simple. And it describes the data structure. All the types, they are reference to other structures, or strings, or maybe arrays. But there is no such thing as a mixed type or anything. So you have really clear defined what data structure should look like. For example, in this example on the slide, you can see there is a shipment structure. It has just two properties. One of them is order ID, which is a simply string, and another one is lines, which is an array of objects, and each of those objects are same structure as this one, called shipment line, with its own set of properties, of course. Then another thing that you can find in services, in specifications, are services. And services are simply interfaces which define what you can do with MCOM. So an example here, we have a shipment management service which has some kind of method signatures in some way. So here we can see a request method which allows us to request a new shipment, and we have find method which allows us to fetch some shipments by some search criteria. And we have another method called ship, which is called when status of the shipment changed to shipped. We can see that each of those methods, we call them more like interactions, they have three flavors. So one of them is a comment. So comment is an interaction, it's imperative interaction, and it meant to change the state of the application. So change some entity in your database, or maybe trigger some process, do things like this. So then you have queries that are inquiry interactions. So those are meant to request data from the service. Like in this example, you can fetch some shipments using this interaction. And then events, they are a little bit special because when we talk about requests and comments and queries, they are incoming interactions. So you have a shipment management service and you can call one of those. But events, they are outgoing interactions. So they are calling, in some way, they are calling methods defined in other services, in services that subscribe for those events. So like in this example, we have shipped event, which means that the status changed. So maybe there are some other services that are interested in this event, and they can subscribe for it. So comments and queries are similar, and when you implementing them, you can see that the implementations are also very similar. But we choose to describe them as different types, different flavors, because the meaning behind them is different. So queries are idempotent, which means you can make as many queries as you want, and it won't change an application state. It won't change the database, It won't change the data. You can cache them. It should not have side effects on how your application works. And then comments, they are imperative messages. So they are requests to do something. They are requests to change your application state. So you cannot cache them and so on. So there is a meaning difference behind comments and queries. So another thing that you can find in specifications called extensions. So the data structures defined by order management system, by Magento Commerce Order Management System. You may notice I say order management system a lot. In my mind, that's pretty much the same, but it's Magento Commerce Order Management. That's the name of the product. So you can find that. So the standard structures, they define what is required by MCOM. MCOM cannot work if order doesn't have ID. MCOM will not work if shipment have no lines, and so on. So it really defines those core data structures. But of course, what we need doesn't mean that it's the same what you need. So structures, core structures, they have this extensible flag, which means that if it's true, this entity, this structure has a special bucket of information attached to it, which you can use to store your additional data. For example, one of our clients is an airport. You heard about Fraport, most likely. And their business model, their way of capturing orders require flight information. So every order you place, they want to know a ticket number, they want to know which gate it is, they want to know when the flight date is. So based on this, they can trigger some actions, they can build some deadlines, like this order needs to be fulfilled before 10 a.m. because the flight arrives at 11, for example, and so on. So if they would use specification, they would build this extension called flight information. Then you can see it extends order model, order structure with 2 additional properties. One of them is a ticket number, and another one is flight date, and maybe there are more. As well, they could define a structure called, for example, flight information, and then use it as a type for one of those properties. This way, they would do the structure itself reusable in case they want to attach the same information to the shipment or to the, I don't know, invoice, whatever, right? So let's try to let me try to show you an example, like how comments, events, and queries works together to build integration. So let's say we have a warehouse management system, we have MCOM, and this scenario that I've been talking through already for a while, we want to ship something, right? So at some point, MCOM makes a decision, okay, all good, stock isn't allocated, it's time to ship something. At this moment, MCOM will make a comment, send a request to the warehouse asking to ship certain items. In warehouse, they will receive this request. Maybe they will persist it in order to show it in the user interface. Maybe not, I don't know. Then the warehouse agent will see it, will confirm, and this is where another comment will be sent to the MCOM confirming shipment. And then in MCOM, this change will be applied. The status of the shipment probably will be changed. And MCOM can dispatch an event saying, okay, status changed. If somebody interested, if somebody wants to send an email, if somebody wants to update their cache, their database, you can do it right now. The thing happened. One of those subscribers could be MDC, for example, Magento Digital Commerce, Magento Store, which can receive this event and update its database. So when the customer goes to the My Account, he will see, oh, this thing already shipped, or already confirmed to be shipped. Another approach will be if MDC would query those shipments from the order management system. Magento Commerce Order Management. Right, so here you can see how queries and events and comments work together to deliver integration, to build integration. And I think with queries, it's more or less straightforward. You need something, you query it from here or there. But between events and comments, there could be some confusion when you use one, when another. So there are some patterns that can be used to describe the difference. For example, comments are normally sent towards source of truth. So we say there is a warehouse, and it has it's a source of truth for shipment requests or picking lists. And MCOM is a source of truth for shipment. That's why we send a comment to our house saying, create a new shipment request. And then we're sending another comment to MCOM saying, change the status of the shipment that you already have in your database. Events, on the other hand, they normally send out of the source of truth. So MCOM owns shipments. And MCOM knows best when shipment status changes. That's why MCOM sends an event notifying about change. Another thing to consider is comments are imperative messages. So they are meant to reflect intention of one system to do something in another. While events, they are more like notifications that something happened. So some way, events cannot fail. Comments can fail. So you say, hey, create a shipment request. And the warehouse system says, I don't know this SKU. I cannot create. So comment is failing. But if event is dispatched, the action is already in the past. The thing already changed. So there is nothing you can say, well, I don't like this event. I'm not going to reject it. You have to follow because source of truth already said that the new status is this. Also, there seems to be a pattern that any comment normally followed by an event, change something, it's changed, and so on. Yeah. So we talked about specification. And specification really defines what you can do, while stays completely abstract about how you do it. So I was doing my best to not say there is a JSON payload, or there is XML, or there is HTTP protocol, or AMQP protocol. So specification really defines those are the things you can do. It's like documentation, but machine-friendly. It stays completely abstract about there is this protocol, that protocol, you should use HTTP header, or you should send this metadata, or I don't know, AMQP property. To actually know how to perform a request, you have bindings to the transport protocol and the format. Those are sets of rules of how you do requests defined by specification using particular protocol. So for example, JSON says, in order to serialize the request in the JSON, you simply use the same structure as you have defined in the specification. If specification says there is a structure with 2 fields, you create JSON object with 2 properties. Then you have binding to the transport protocol, which simply defines, okay, so you have this payload serialized already. You have some metadata for this payload, like what kind of interaction it is, what version, what format, whatever. And then it defines how you send a request over transport protocol. So for HTTP, it says, okay, you need to post it to this payload with this certain header. In the AMQP, it says you need to send a message, and the payload of the message will be a serialized payload of the request, and the headers should be those. So at the moment, MCOM focused, one of the things that we invest a lot, and it was our primary focus, is to build JSON over AMQP. It really brought this constraint of enforcing asynchronous communication. And asynchronous is great. I mean, if you can do something asynchronous, you should choose it over synchronous, because it really allows you to scale. It allows you to build powerful integration. It allows you to decouple applications. I'll have another slide which shows this. So first thing we did is JSON over AMQP. And next thing we did is JSON over HTTP. So this one, I think, will be released very soon. But basically, it's a synchronous communication, and HTTP is most popular protocol in the world. So we choose HTTP, and this is post factum standard for web APIs. So let's get closer. Let's see what JSON over AMQP looks like. So in JSON over AMQP setup, this is what defined by protocol binding, basically. We have one AMQP server that is centralized messaging bus. You can have one server or cluster of servers. And then every system connects to this AMQP server, and they exchange messages. So the smallest thing in the request in the AMQP protocol is a message. And the message, its payload, has arguments for your interaction, and the topic of the message is basically name of your interactions. And then every application, so the way topology inside the AMQP server organized is like a post office. So every application has an inbox and outbox. And then if you want to send something, you simply build your envelope, you put to MCOM, to MDC, then you put the payload, you put the topic of the message, and you send it to the outbox. And then AMQP server gets this message routed to the right queue, to the right inbox. And then if you're interested in some messages, your application simply creates bindings to the inbox saying, I'm interested in order shipped message, or shipment shipped, or this request, or this query, or this comment, And one of the things that I would really love to highlight about the AMQP protocol is robustness. So if we look at the normal integration, there is an MCOM and Warehouse once again. So what will happen? MCOM decide it's time to ship something. But Warehouse system is down. I don't know, it's not available, the network problem, whatever, right? So what will happen is MCOM will fail to send a request. And it's good if we, in the user interface, and we can show a red message saying, sorry, no good, try again later. But what if it's an automated process? What if this message, with this decision that it's time to make this request was made in the automated manner? We need to think about automated retry. So that brings complexity inside the system which initiates a request. But if we simply put an additional step here, if we put MQP server and decouple mcom and varhouse by saying, okay, mcom doesn't need to talk to varhouse. Maybe it does not even know that there is a varhouse. And then varhouse doesn't need to directly expose API to mcom. So in this scenario, what will happen? So varhouse is down, but mcom still can send a request. So the message, we're talking about asynchronous request. Synchronous is a separate story. But synchronous message will get to MQP server, and then MQP server will just persist it, waiting for varhouse to start message consuming. mcom in this scenario doesn't know that the varhouse is down. It will just carry on like nothing happened. And because the request is asynchronous, it will not matter. It will be completely transferred for mcom. Then once varhouse is back, the message will be delivered and processed, of course. And I mean, for mcom, again, the process is completely transparent. For mcom or whatever application initiates the request, it works both ways. So the next thing is JSON over HTTP. This is quite straightforward. So every application exposes an HTTP endpoint in which you can post messages. There are, again, a bunch of rules of how to compose the message, what headers should it have, and so on. And then there are peer-to-peer connections. Every system knows about every other system. They connect directly. And yeah, basically that's it. It's very simple, very straightforward. You can introduce some gateway API gateway to make a centralized point, because with this kind of setup, it's a bit hard. For example, if you have event to broadcast and you, by some reason, cannot use IMQP, you would need to call multiple systems, make multiple requests. That probably will be terribly slow. So maybe you would be interested in using IMQP or building an API gateway, which will do it for you. So because specification is really, really abstract about the protocol, it's really about, you can create any binding to any protocol. If tomorrow we decide that, HTTP is not fast enough, we could use Google RPC, for example. We can use, I think it's called protobuf, the serialization format, and we can use Google RPC to actually as a transport layer. So specification really stays abstract about this, and we can create as many bindings as we want, and then we can switch between them with minimal effort. Which actually brings us to the point where we can say, in our client library, we can actually make a smart decision about what to use, which protocol to use depending on the message. So for example, if we want to notify another system about some event happened, we can use MQP because it's asynchronous, it's fast, and so on. If we want to make a query, probably we want to use synchronous protocol like HTTP. By the way, IMQP in our implementation supports both synchronous and synchronous. It does IMQP RPC requests for synchronous. It works. It's not as easy as HTTP protocol, but it does its job. So IMQP actually supports everything. With HTTP, it's a bit tricky because you need to do kind of service discovery yourself. You need to do broadcasting yourself, and so on. Okay. So this is not just theory. We have an actual project using this specification and those transport bindings. So mcom integration with MDC, or MDC integration with mcom, uses this approach. We managed to do all comments and events asynchronous so far, which give us ability to leverage all the power of IMQP and this robustness that it gives. But even though they are all asynchronous, it still gives us this nice close real-time experience. So once user places an order in MDC, it appears in mcom within a second, even less, just a few moments. It's amazing how fast it is. And and all other communications like stock updates, auto status updates, and so on, they also very fast. And basically this integration, it covers a catalog integration, which is basically synchronizing products with PIM. In most of the cases, MDC is a PIM. So this is a standard setup, but any PIM could send a message of product update, and then it will be integrated with that system. Then we have sales, of course. So this is orders, shipments, and everything that goes with order. Then we have post-sales. So those are returns, refunds, credit memos, all those parts. And then inventory, of course. And then there are some other less important integrations. We have a lot of time. I went faster than I thought. But yeah, we are wrapping up. So the specification is public. It's published on our GitHub. It's called Magento-MCOM. It's our organization where we publish our stuff. At the moment, we have quite few specifications published. In coming weeks, I think we will publish more. There is a very good blog about Magento in general, and also MCOM and the company, MDC, MCOM, everything. Alan Ken doing a great job. You can see find some updates on this as well there. And well, we want to publish more. We want to publish more tools, more specifications. So yeah. Thank you very much. That's it. I would love to hear any questions. We have a lot of time, actually, so I can answer a lot. And actually, any feedback would be great. We're really looking into this for feedback.
Hi. On your feature list, you talk about inventory management, and I'm wondering if that also includes a stock reservation system, which is something that Magento currently lacks, which causes some nil picks sometimes if the stock isn't fully up to date. But obviously, when people are checking out at the same time, especially during peak, then that kind of fails a little bit. Right. Is that something that would be included in this, or is inventory management just a stock reservation system? Yeah.
So it's called. Well, it's partially inventory management, partially sourcing. So this is a part of MCOM. So when we say MCOM, it's a Magento Commerce order management. But if you listen to Rob's session today in the morning, he said that it's order management system, but it's all about inventory. It's main thing of the whole service is to manage inventory, manage it fast, manage it smartly, and so on. So yes. This also, through this specification, we will also expose API to work with stock, and the whole synchronization process and everything will be done through this approach, using this approach. Yeah? No?
Sorry, I have another question. What kind of warehouse management systems have you integrated with, or do you know that people have integrated with, and are there any public sort of integrations for that kind of stuff?
Okay. So there is one called, I've forgot names, but they are not like public APIs, and their API is more of feed-based. Like you have an XML feed, you generate it, you put it on some SFTP or whatever. So for the moment in MCOM, yeah, so most of integrations, they feed-based, but they feed-based through this integration layer. So we generate a message and we convert message in the feed. Yeah, makes sense? Thank you. Another question?
Hi, I have a question. You said that this MCOM system can integrate with Magento. Do you offer any extensions for that or anything like that? Or how do you integrate Magento Store with MCOM?
So the extensions, yeah, so basically our team developing extensions for integrating Magento with MCOM. So there are, I think, like 4 or 5 for different areas. So one for catalog, one for inventory, one for sales, post-sales. Yeah, that's pretty much it. So extensions are, hopefully will be open source at some point. At the moment, they are there. And once you sign the contract, you get in them. Okay,
and then the integrations between MCOM and any third party, how does it look like? Like you provide it, you help integrate, or?
So our focus that we develop integration with Magento, obviously. But the specification is fully open. Well, it's partially open for the moment, but the roadmap is to completely open it, let anybody have access to this. So you have access to the documentation generated from XML, and then you have access to the XML. So you can use it, for example, if you're using it for PHP, if you're writing your integration in PHP, you can use existing code generator. We have one for MDC, but for any other, you can build it yourself. So you can use XML to do code generation, validation, whatever, and build this integration yourself. So there is no existing integration for other frontend than Magento, but we encourage, we actually will be happy if you will create one for, I don't know, Dreamwearer.
Sorry, I have a last question. You said it's a cloud base.
Correct.
So who provides the infrastructure and is maintaining the infrastructure and so on?
Right. So it's a cloud base. It's not like Magento cloud base. It's a SaaS offering. So you sign the contract, you're getting resources, you leasing basically the order management system, and then we take care of everything infrastructurally. So you're getting some API endpoints, and you can work with this.
Okay. And you own the code and you maintain the code?
Yes. Overall, you can see the difference, but I tried to explain it a little bit, that MCOM is really not about being client-facing. It's just a bunch of wires that wire up together different things. So we want to make it as easy for you to use as possible, and I think maybe MDC would be cloud-based as well, but with MDC it's a special story because you really want to own the look and feel, the branding, the experience. So with MDC we went PaaS, more or less, it's a PaaS. But with MCOM, yeah, it's a SaaS offering.
Thank you.
Thank you very much for your question.
Hi, I've got a question about inventory again. So we've got inventory in different places. So we've got stores, we've got a distribution center. Does MCOM provide a single view of that stock? Can we do advanced things like at a very busy time? Can we stop the distribution center from fulfilling orders? Can we disable stock locations basically?
Yeah, so this is what MCOM does. This is what MCOM is for, actually. And sorry, I'm not really expert. I'm an engineer, more of a business expert. I think Rob would be a better person to ask this question, but basically, yes. What MCOM does is bringing this omnichannel experience. So you can collect stock from different locations, different stores, pick-up locations, whatever, I don't know. Any place where you have stock, you can add it to the MCOM, you can send updates, and then what MCOM does, it builds those aggregations around availability zones, and it basically does this calculation for the final number of how much you have here, how much I can reach from here, from there. And then you have sourcing engine, which is another subsystem of MCOM, which actually does smart decisions on where you want to ship it from. So it really takes a lot of factors in the account, like maybe there is a lot of reserved stock, so it's closest, but I'm not going to take it from there. So it's a flexible system that helps you to make those smart decisions and manage your stocks in a good way. And then the integration layer is basically provides APIs for those. So you can say how much stock I have in Spain, and it will give you a number. You can send updates from the warehouse, so you can build integration. Yeah, thank you. Yeah, if you want, we really can, meet after the presentation. We'll be happy to. No, come on, ask the question. We have 21 minutes.
I think you sort of covered it a little bit, but it's mainly about shipping methods. So obviously, like collect and store and stuff, which a lot of people are offering now, as well as delivery. Does it offer anything around sort of weighting different shipping methods for maybe like complexity or overhead? Sort of just for us as a business, for example, it's very difficult for us to fulfill from store, especially during sale, because our staff literally have to go onto the shop floor, pick that item, and package it up. While in distribution centers, it's a much more seamless process. So is there something, or is that something that's built in of an idea of a complexity of a shipment?
Definitely we are thinking about this. And definitely this is one of the challenges why MCOM is there. This is one of the problems that we are trying to solve is to do this smart stock management. And again, unfortunately, I'm not like the best expert in this, so I can tell you that there is an API for that. But yeah, this is one of the problems we are trying to solve with MCOM. This is all questions you ask. This is exactly what what we have in our backlog. Like we need to help them. That sounds like this. So I think you will find it very interesting to catch Rob Sweeney somewhere. He's really into this, and I think he will give you a better idea. Well, thank you very much. We still have some time, but thank you very much for questions. And feel free to reach me anyway and talk. I will be really happy to share our experience of doing integration. Thank you.